Hello everyone, I am taking this time to make this recording about complex numbers because we haven't been able to meet for the physical class because of other commitments, and therefore I hope this video will make you understand better complex numbers when you follow it alongside the notes that we have for our class. And therefore, without wasting any time, we will ask ourselves, what is a complex number? What is a complex number? And of course, a complex number, just as the name suggests, it is a number that is combined, a combination of a real number and an imaginary number. And therefore, a complex number is a number that can be written in the form, A plus BI. And in this case, A and B are real numbers. A and B are real numbers. Then I is what we call iota. I is what we call iota. And therefore, any number that can be written in that form, A plus BI, is what we are calling a real number. Now, this real number has two parts. We have the first part, which is this A, which we call the real part. So that A is what we call the real part of that complex number. And then we have this part B, that is B is what we call the imaginary part. Okay, that imaginary part is part B. And then of course we have I, which I've called iota. I've called iota. And therefore, real numbers will be in the form of A plus BI. A plus BI. That is a complex number. And just the same way we work with real numbers, complex numbers are there. It is a number system which all operations that can be performed on a real number can also be performed on a complex number. And therefore, as we add, subtract, multiply, and divide real numbers, we can also do the same, and it is possible to work the same operations on complex numbers. So in our operations, we'll be treating our I as square root of root 1. So we'll be treating our I as square root of root -1. And in this case then, if you want to find the value of, to remove this square root, of course we say you square both sides, and therefore on your left hand side you'll have I squared equals -1, because the 2 will cancel the root. This becomes I squared equals -1. So in our arithmetic computations, we shall be treating I as root -1, or -1 equals I squared. -1 equals I squared. Okay? I hope for complex number, the constituent and what those symbols mean, it is well understood. Now let's look at addition and subtraction. Addition and subtraction of complex numbers, because we need to learn how to operate them the same way we operate real numbers. and any other form of a real number. So the thing that you should note here is that complex numbers, just like real numbers, they are added by treating what we call like terms together. Like terms together. So by like terms together, we mean since a complex number has two parts, the complex, the real and the imaginary, when you shall be adding two complex numbers, let's say z equals a plus bi, right? A plus bi, that is z, and you have another number, complex number y equals again a plus bi. These are two complex numbers, z and y, or y and z. And therefore, what I mean by like terms, you look at the real part of both these numbers, that is a and add them, and then you look at bi and bi and add them. Those are like terms. Those are like terms. Now, let's be a little bit more specific on the choice of these complex numbers. Consider two complex numbers. Consider these two complex numbers. So you have the first one as 2 plus 3i. Remember, a is a real number, and therefore 2 is a real number, and 3b is also a real number. We said a and b are real numbers, so 3 is also a real number, but this part is imaginary because it has the iota. It has the iota. So consider these two numbers, 2 plus 3i and 5 plus 6i. Again, 5 and 6 are real numbers, then plus that iota. So we want to find the sum of these two real numbers. So adding, let me make sure that one is clearly captured. Adding the two real numbers, we get, so let's see, we have 2 plus 3i, that is one real number. Then we are adding 5 plus 6i, right? That is addition. This is our sign of consideration. Of course, this sum is there, it exists naturally when we are defining a real number. So the rule is to add like terms, put like terms together. So you look at the real part and put it together, and then the imaginary part again put it together. And therefore the first step would be having 2, which is the same as 5, which doesn't have a iota or an iota, and then you can assemble that. Then half plus the first term here again is 3i and 6i, 3i plus 6i, and that gives you what? 2 plus 5 is 7, and then plus this plus, of course, 3 plus 6. Remember, this I is an unknown. The same way we say 2b plus 3b equals 5b. We treat b as an unknown. So here we treat I as an unknown. Okay? We treat I as an unknown. Therefore, we'll add the real numbers, 3 and 6. That will be 9i. So adding these two complex numbers, 2 plus 3i, 5 plus 6i yields 7 plus 9i. we get 7 plus 9i. If we were subtracting, assuming we are subtracting these two complex numbers, again the rule applies. That is, put like terms together. Now, let's see. Suppose you are given, suppose you are given these two real numbers. We have 1 minus 3i, and then of course another complex number as 4 plus 2i, right? 1 minus 3i and 4 plus 2i. Of course, the sign between the real and the imaginary part can be plus or minus. That's what I have said. A complex number is made up of two terms, and terms are separated either by addition or subtraction. Okay? So, we want to find the difference. Find the difference. We want to find the difference between 1 minus 3i and 4 plus 2i. And of course, it will be formulated as 1 minus 3i, and then all that subtract 4 plus 2i. Again, like terms together. Like terms. So, like terms. What are the like terms here? Of course, it is 1 and 4. So it will be 1, okay, minus 4. Okay, 1 minus 4. And then we have the imaginary part, which is 3i, negative 3i, and 2i. And it's subtracted, and therefore I'll have minus 3i, which is here, then minus 2i. Okay, minus 3i minus 2i. Yeah, I can put the minus inside because the 3i has a minus, and this, when it opens again, it becomes a minus. And therefore, that will mean that I have minus 3, then minus 5i. Again, minus 3 is a real number, minus 5 is a real number, and then plus the iota. So, you can have, let me bring that up so that you can be able to see it. So any form of a real number that you get, you can be able to formulate, or you can be able to either add or subtract. You can be able to add or subtract. Okay. Now, you'll find more notes, you'll find more examples on the notes about addition and subtraction, about addition and subtraction of those complex numbers. Okay, just something I need to emphasize is that it is possible for two non-real numbers or two complex numbers to add to form a real number. It is possible that if you have x, which is a complex number, a plus bi, and a y, which is also a complex number, when you add x plus y, you get a real number without without an iota. It is possible. For instance, consider when you are given 1 minus 3i, for instance, 1 minus 3i, okay, and then another number 1 plus 3i, or even 2 plus 3i. Notice this part is a minus, this part is a plus. So there is a likelihood that the 2 will cancel out. 2 will cancel out. But let's see, we want to add. So we'll have like terms together. So we have 1 minus 3i plus 1 minus plus 3i, sorry. So those are the two complex numbers that we are adding. And therefore, we put like terms together. It will be 1 plus 1. And then plus, I begin with minus 3i. Then plus 3i. So when I add 1 plus 1, I'll get a 2. When I have a debt of 3 and I have an income of 3, so I'll have to pay that debt, and therefore what I'll be left with is a 0i, because minus 3 plus 3 is 0. Any number times 0, whether imaginary or real, is 0. So this part is 0. What I'll be left with is just what? The 2. So those two real numbers, those two complex numbers have added up to a real number which doesn't have the imaginary section. Okay. Okay. In the same spirit, let's look at multiplication or product. Multiplication of complex numbers. How do we work with complex numbers when we want to multiply? Before we look at any example, I want us to remind us of the powers of I, what we call powers of I, because most likely we will be multiplying an I and another I, and therefore when we multiply that, it means we are likely to get I squared, okay, I squared, I cubed, I power 4, all those things, and therefore we need to know what that means. Remember we said I equals root negative 1, and therefore when you multiply I and I, you get I squared, which is negative 1, okay, which is negative 1. So it is likely that you can also multiply negative 1 with another I, or I squared with another I. You still get I cubed, and I cubed is referred to as negative I. Okay, I cubed is negative I. Why? Because I have an I and I'm multiplying by I squared, so it will be negative I. I hope that is clear. Since I squared is negative 1, so I'm taking I cubed, which is I, okay, times I squared, and therefore I will have I times negative 1, and therefore I will have negative I. That's what that concept means. Then finally I'll have I power 4, where it is equivalent as taking I squared times I squared. So this will be simply negative 1 times negative 1. I hope that is visible. Negative 1 times negative 1. Okay, which will give me a 1, because it will be negative 1 squared. Therefore, I power 4 is 1. We are going to look at that. And again, when you go to I power 5, again, it goes back to I, because it will be now I power 5. It is the same as I times I power 4. Okay, and I power 4 is 1. Therefore, I'll just have 1 times I, which is I. So I power 5 is I. But those other powers, you can be able to formulate them easily. You can be able to formulate them easily. That is I power 4 times I. That will be 1 times I. It will be I. Okay. maybe now we can go down to the product of complex numbers. And complex numbers can be multiplied using an algorithm we call FOIL. These are initials, the same way you had SOHCAHTOA in high school. You were referring to trigonometric identities using that algorithm, SOHCAHTOA. I'm talking of algorithm. An algorithm is a relationship or a simplified kind of a formula that will help you to compute these complex numbers. Now, what does FOIL mean? What does FOIL mean? That is what you should concern yourself with. FOIL is an initial, those are initials. So F stands for first. So when you are multiplying two complex numbers, multiply the first terms first. First terms first. And then we have O. O means outer. And then after multiplying the first terms, add the product of the outer terms. Outer terms. Oh, it is not seen. I think that is visible now. Outer terms. That is O. Then the next is I. I means inner terms, and then of course L means last terms. Now, assuming you are given two real numbers, x as a plus bi, okay, and y as let me take a different format, c plus di. C and d are still real numbers, so we can pick any of the real numbers. You can even have x plus y, you can even have p plus q, qi. So suppose we are to multiply x times y. Suppose we are to multiply x plus y. So we are to follow this algorithm FOIL. So x plus y will be a plus bi. Then I'm multiplying that by c plus di. Okay. So now look at what that means. It means in my multiplication I should consider the first terms. A is the first term in x and c is the first term in y. A is the first, c is the first. So first I'll have a times c, then plus. Okay, you see that? A plus c, first terms. So these are first terms, what begins on each of the numbers. Then the second order is outer terms, the farthest from each other. So the outer term for a, for x is a, the outer term. So this is the most outer, term. So I'll have a and di, a times di. Okay, I add the inner terms. What is the inside? It is b and c. These are the most closest, to each other. Again, I'll have bi times c, because bi and c are close to each other. And then the last term. Is the last. If this was the first, then the last are the ones with i's. So I add bi, so this is addition. I'll add bi times di. Okay. So I'll have multiplied those two complex numbers, except that now I need to work on how to simplify. Okay. So again, I have to put like terms together, the ones with one I and the ones with two I, and so on. Okay. Okay. Now let's do this. A times C is AC. Okay, A times DI is ADI. So I'm just looking at the ones with I and I. B plus C, BI times C, it is plus BCI. I'm multiplying, so I can multiply B and C. Okay, and then what was remaining is B times D, which gives me a BD. Then I times I is I squared. I times I is I squared. Now again, simplifying further will give me AC. Okay, AC. One thing you should ask yourself, what is I? So you can put these two together. You will have AD plus BC, then multiplied by I, because you can just factor out I. Factored out I. But again, you need to ask yourself, what is I squared? From our powers, I squared is -1. See that? I squared is -1. And therefore, what this becomes is just -1 times BD. And in simple terms, I have now AC. BD times -1 is just minus BD. It's just minus BD. So let me just bring that minus. Because I'm also looking at like terms. Those terms that do not have I, this will not have I, this will not have I. So I will just bring it BD. You can group that, then plus the other group, which is here. AD minus, not minus but plus BC, then all that multiplied by I, That will be the product of those two complex numbers. Now, maybe more specifically now, we can choose actual numbers instead of A and B, C and D. We can choose actual numbers, like for instance, consider the product. Maybe you can write, consider the product. This is 2 plus 3i, and then we are multiplying that by 4 plus 5i. Okay, consider that product. Well, remember the FOIL. Therefore, what you just take is, this is what we are given. We are given 2 plus 3i, and then we are multiplying that by 4 plus 3i. Okay, what should we be able to get? That is the question. Well, what we get is we follow the FOIL algorithm, where F stands for first term. So the first multiplication will be between the first terms, which will be 2 times 4 plus. The second product should be between the outer. The outer is 2 and 3. This is first. This is outer. Okay, the outer will be between 2 and 3i, so you'll have 2 times 3i. Okay, plus, as we continue, the third order was inner. Inner are those numbers that are close to each other, inner. And therefore, inner will be 3i times 4. Was it 3i or 2i in my original? 3i and 5i. Okay, let's work with what we have. It should have been 5, but it's okay. Let's have 3i and 3i, no problem. Since it is a number, it's a complex number. Okay. And then the last order is where you multiply the last. So in the first complex number, 3i is the last. And in the second complex number, 3i is the last. So I'll have plus 3i times 3i. 3i times 3i. And that will simplify to some form. So 2 times 4, of course, is a real number. It will be 8. So 2 times 4 will be 8. Now, plus 2 times 3i will give you 6i, because 2 times 3 is 6. Again, plus 3i times 4 will give you 3 times 4, which is 12i. And then finally, 3 times 3 is 9. I times I is I squared. Okay? But remember, I squared is -1. Remember that. I squared is -1. Now, this narrows down to 8. 8 has no partner until we simplify 9. Then 6 plus 12 is plus 18i, because both of them have a single I. So they are